Hi friends, welcome back. Today we are going to solve Codeforces problem nested segments. Before we start looking into the problem details, some examples and its solution, I want to mention that my channel is dedicated to help people who are preparing in their Java J2 interviews and for their coding interviews. You will find a lot of helpful videos on my channel that can help you in your Java J2 interviews and for your coding interviews. On my channel, there are over 200 solved different coding problems from previously asked interview questions by Google, Facebook, Amazon, Yahoo, Apple, and many other big tech companies. And those coding problems are selective in the sense that they constitute important coding questions varieties such as graph problems, binary search tree problems, DFS, BFS matrix related problems, linked list and string related different coding questions, as well as dynamic programming questions. So this channel can definitely help you in your job interview preparation. So please subscribe to the channel. So let's first go through the problem statement of nested segments problem, and then we'll go through some examples and formulate the solution for this one. So you are given a sequence of A1 to AN of one-dimensional segments numbered 1 through n. Your task is to find two distinct indices I and j such that segment AI lies within segment AJ. Segment L and R lies within segment L2 and R2 if L1 is greater than equal to L2 and R1 is less than equal to R2. Right, so print indices I and j. If there are multiple answers, print any of them. Right, if there is no segments which is contained with other segment, right, then we have to print -1 and -1 in that case. In the input they have given us the first line contains one integer n, which is number of segments. So as you can see, 5 segments are there, and these are the starting and ending points of each segment is given to us basically, right? So we can just if you look at this first example, right, then there are 5 segments, and as you can see, the second segment, like the first segment start from 1 and it goes till 10, right, and second segment start at 2 and it goes till 9. So second segment is contained within the first segment, right? So we have to answer, we can answer here 2 comma 1, right? So it means that second segment is contained within the first segment, as you can see, right? Because 2 is greater than or equal to 1 and 9 is less than or equal to 10 basically, correct? So that, as they have given us, then only the segment will be contained, right? So here they have given us this condition. So let's take some example on the whiteboard. So this is another example that I created for our explanation. So let's first go through this example. So segments are given to us. So if you just draw a simple line on the XY graph, let's just first understand like this graph. So if you just go on XY plane, right? So this one is 0, right? 0 comma 0. So first one will go from 1 to 0, right? So this is, let's say this is 1, then this is 2, let's say this is 3, this is 4, 5, 6, 7, 8, 9, 10, right? 6, 7, 8, 9 and 10, right? So the first segment will go from 1 to 10. So let's just plot that segment here quickly. So visually it's easy to understand the problem. So 2 comma 12, so another will start at 2, right, and it will go till 12, right? So 2 to 12. So let's say that this is 12, right? Let's just say that this is 12 and this is 11 here somewhere. So the next segment, if you plot, it is 2 comma 11, right? So 2 comma 11, so it will again start at 2 and it will go until 11, right? So it will, let's say, go until here. Then 2 comma 9, so 2 comma 9 is 2 starts at here and it goes till 9, and then 3 comma 9, 3 starts at here and it goes till 9, right? So um, so first thing is, you would have noticed here is, after we get these input segments, we are going to sort these segments, right? So these are the sorted segments, as you can see, right? So how they are sorted? So the starting point will be ascending. So as you can see, 1, 2, 2, 2, and then 3. So this is the starting point will be ascending, and the ending point, if both are same, then it will be descending. So for example, in these 3 cases, right, So all these three segments start at 2, but they are ending at 12, 11 and 9, right? So they are ending at different points basically, but we are taking it in descending order. So as you can see, 212 is coming first, then 211, then 29, right? So this is the way we will be actually sorting the segments first. And as you can see, after we plot these segments here, then this segment, if you consider this segment is contained within this segment, right? Because this is 2 comma 11 and it is 2 comma 12, right? So 2 comma 11 will be contained within 2 comma 12. So if you map the indexes here, right? 1 2 3, then 4 and then 5, right? So you can say that we can answer the, so 2 comma 12 is basically 2. So we have to say that 4 is contained within 2, right? So that is the format, correct? So 2 is 2 comma 9 and it's contained in 1, right? So 2 4 comma 2, right? So this is what we have to answer. It is at least this is one of the segments which is content, right? Now you can also say that this segment contains in this segment, right? Or this segment also contains in this segment, right? So there are a lot of combinations. In this case we have multiple segments which are contained with some other segment, right? So we can output any of them. So in this case we will just, once we find out the first one, then we'll just output that one. So in this case we will find out 4 comma 2. So as you can see, the 2 comma 11 is contained within 2 comma 12, right? So that's what we will output. So so first thing is to solve this problem, the first important thing you might have noticed is that the sorting will be very important factor in this case, right? Because we have to first sort the segments, because after the sorting is done, then it will be very easy that we can go one by one after sorted segments, and then we can figure it out, like which segment is contained within which is another segment, right? So for the segment, I just created one segment class. I'll show you. So that is the kind of a bin, you can see like Java bin, right? So segment pair is a class that I created, and it is a comparable, right? It is implementing comparable interface. So there are three fields: left, right and index, right? So left, right is the left boundary. So this is the this is the left boundary one, and this is the right boundary where the right boundary of the segment is, and index is the position of the given array, right? The segment position in the given array, like 1 2 3 4 5. So so we created that bean class here, and we have implemented compare to method, right? So we can compare segments with other segments. So as you can see, left is, we are doing left in such a way that left will be increasing order basically, right? So you can see this left is increasing order. If you just see this part, this is increasing order, and if you see just the right part of the segments, this is increasing, or like this is decreasing order basically, right? So so this one, actually what I mean to say is if they are same. So what I mean to say is if they are same, right? Like 212, 211 and 29, then if left is same, then the right will be in descending order, right? So this is what we are doing here actually, as you can see. And otherwise we will just use the index, right? So this is the compare to method that we implemented. uh, so we just created this abstraction, right, to capture the all segments. So let's just go through this one example. This is the one example that we just went actually, right? So first we will go through the given segments here, and we will actually create our segment pairs, right, from the given input. Like for example here 1 comma 10, right? Then the index will be 0 in this case basically. As you can see, we are reading the input in 0, in 1. So in 0 will be 1, in 1 will be 10, right? So we are creating segments, and we are creating array of segments here, right? This P is the array of segments. So after that we will do arrays sort method, so that we can sort the segment pairs, right? So this one is the sorted segment pairs, right? So as you can see, so let me show. So this is the sorted segment pairs basically. So 1 comma 10 is first, then 2 comma 12, 2 comma 11, 2 comma 9 and 3 comma 9, right? So this is the sorted array we will get after sort. After that, what we will do is we will use TreeSet, right? I'll tell you why we are using TreeSet. So first thing is we will put the left, like right value into the TreeSet, right? So let me just actually remove this coloring so we can reuse this space. Okay, so now what we will do is we are at the first segment, right? So we will add this 10. So we have the tree set, right? This is tree set, let's say. So in the tree set, we will be adding 10 here, right? So in tree set, why we are using tree set? Because it will always keep the keys in sorted order. So we put 10 here. After that, we will go through our this array, right? This array we will go through one by one. From we will start with 1 basically, right? Because for the first one we already added that into the set here. After that we will start with 1 and we will go one by one. So let's just go quickly so you will understand why we use tree set. So after that we will put 12 into the tree set, right? So first we will check if there is any value which is smaller than this value, right, in the tree set. So let's go back here. So as you can see, we are reading from the right value from the array and we are comparing if there is any value which is bigger than that value basically, right? So is there any value which is bigger than 12 in this array? No, right? So we will add that basically. When we are doing 10, there is any value bigger than 10. First let's start with beginning. So any value bigger than 10? No, so we will add it here. Is there any value bigger than 12? We will add it here. Is there any value now we are at 11, right? Is there any value which is bigger than 12 here? Yes, there is a value, right, which is bigger than 12. So whenever we find a value which is bigger than 12, what it means for us is that there is an interval which is already bigger than the current interval, right? So if you look at this one, so current interval we are looking is 211. So now whenever we find a value, like for the right side, right, for the right side, if there is a value in the tree set which is bigger than this 11 value, it means that we already have seen this past interval. We have seen an interval which is bigger than current interval. So the current interval can be contained with this interval, right? So current interval can be contained basically, right? So if you plot 2 comma 12 and 2 comma 11, 2 comma 11 is smaller than 2 comma 12, right? It can be contained basically, right? So for example 2 comma 12 is here, let's say. So this is the interval and 2 comma 11 will be like for example here, right, 2 comma 11. So as you can see, this interval is contained with this interval, right? So we have to just output the indexes of these intervals, right? So first we will output the uh, let's say what is the format. 2 is the basically the smaller interval first we have to put. So smaller interval in this case is 211, which is 4. So 4 we have to put into our answer, 4 first and then 2, right? Then 2 is because 212, right? So this should be our answer. So let's just make sure so as you can see, this is what we are doing, set dot ceiling c, right? Ceiling method will return us the if there is any higher value available in the set, right? Higher value than the c, right? So for example, higher value than 11 is 12, right, which is available in this case. So that is what we are checking here, and then we will get that value here, the d value from the set, and then we will check if the jth segment is contained with ith segment, right? So basically we will go from the all the intervals that we had seen before this current interval, and whenever we find the right is equal to d, then we will take that, right? For example, what we are doing here is we are going through these uh, so when we are at 2 to 11, we have already seen these two segments, right? So we are going through one by one and we are checking if this value 12 is equal to the value that we have seen, which is greater than 11 into the tree set, right? So this 12 and this 12 will match, and in this case we will uh, uh, pick them right into our answer. That's what we are doing here. So as you can see, checking whether jth segment is contained within the ith segment, right? In that case, we will just put the segment j segment as the answer, and here we are just outputting ith index plus 1, and the answer is this one, right? Answer index plus 1, right? So it means that I is the bigger segment basically, right? I is the bigger segment and answer is the, sorry, I is the smaller segment. This is just confusing. What is the format? Let's see. So this 2 is the, basically this first is the smaller segment, right? So smaller segment we are putting, ith is the smaller segment and the answer is the bigger segment, right? And then we will just exit. Otherwise we will add the right into the set, right? As you can see, we are adding the into this set basically, right? 10 then 12. So that's what we are doing basically here. If we don't find any segment which is contained within some other segment, in that case, if we reach here, then we are just going to output -1, right? This is the case when we do not find any segment which is contained within some other segment, correct? Because as you can see in the problem, they have said that if there are no answer exists, we have to print -1. So let's just quickly execute this example that we have just seen. So now we are getting 4,2, which is the correct answer. As you can see, 4,2 is the correct answer. So let's just try some examples. Let's just try their example that they gave us, right? This is the same example. This is another example. So I'll just comment out the example that we had just seen, and we will use their example now. So this is their example, right? So this is a little bit different. So this is the first example that they have given us. So we should get 2,1 in this case, right? So let's just execute this code. So we are getting 2,1, which is the correct answer. So after that, we will just take one negative example that they have given us. So let's just take this negative example and make sure it also works. So in that case, we only have 3 segments. So 1, 5, 2, 6, 620. 1, 5, 2, 6 and 620, right? 6,20. 620. So this is the example that it should give us -1, right? Because as you can see, all the segments are different, right? They cannot be contained with anything. 1,5 cannot be contained in 2,6, right? 2,6 also cannot be contained in 6,20. So that's why it is -1. So as you can see, we are getting correct answer -1 here. So this way, all the examples are like these test cases are getting passed. So this is the way we can solve nested segments problem on Codeforces. So what we did is we created one abstracted class actually to capture the segments, right? Which is called as segment pair. We created left, right, and index. So left is to capture left side boundary of a segment, right to capture right side boundary of the segment, and index is to capture the index in the input, right? Excuse me. So after this, first thing is we have prepared an array from these segments, and then we actually sorted this array, right? This is the sorted array of the segments. Then after that, we will go through this segment one by one, and we will keep putting the value of this right side into the tree set, right? If there is no higher value present. So 10 we will put, then 12 we will put. When we are putting 11, we will check and we find higher value 12 is already present, which means that we have already seen an interval which is bigger than the current interval. And why it is assured that it is bigger? Because the left side is always in increasing order, right? So it means that when we find a right side which is bigger, we don't have to worry about left side, because left side will be always in increasing order. So we don't have to worry about left side, because that is the way we have sorted this array, right? So as soon as we find any segment which has bigger value on the right side than our current right side value, then we will take that segment into our answer, right? and once we find that answer, we will just break out. Basically, as you can see, we just printed the answer and we are just doing breakout from that loop basically. So this is the way we can solve the Codeforces problem, nested segments. It's a important problem to understand and important from coding interview perspective, because there are similar problems like nested intervals also. You can check on Leetcode also, there are similar problems which can be solved like this sorting logic. If you are new to my channel, on my channel there is a dedicated playlist for Codeforces which has a lot of solved Codeforces problems explained with examples and Java code. There are also another big playlist called as Leetcode and Leetcode solutions. It has a lot of important problems which are coding problems asked by Apple, Amazon, Google, Facebook, Microsoft, Yahoo, and many other big tech companies. Those are like really lot of varieties of problem you will find there, that includes BFS, DFS, matrix problems, dynamic programming problems, graph problems, as well as binary search tree related problems, binary search related different coding questions, as well as problems related to linked list and strings. So if you practice those playlist, you will I think you can practice almost all varieties that are possible in the coding interviews. um, if you like this video, if you find it helpful, and if you like the way it's created with whiteboarding session and examples and Java code, please give it a like. Also subscribe to the channel. Your subscription to the channel is really important for us, because that is the way the videos can reach to more people who need help in solving coding problems. They can watch these solved coding problems videos and learn from them how to approach different coding problems, and what data structures in Java and what libraries and APIs to be applicable to solve different varieties of coding problems and logical problems. Because the goal of the channel is to help as many people as possible in their Java interviews and in their coding interviews. So if they can watch these videos, they will definitely get benefited. If you like this video, please give it a like, share this video with your friends and colleagues. If you have any questions regarding this video, please put your questions below the description. um, Also, if you have any questions, you can put it below the description section. I'm going to put the Java solution code in my GitHub account. You can take it from there and check it out. There are a lot of solved GitHub account code on my account already put there. The Java solutions are there. You will find it there, which can be helpful. So thanks for watching this video.